All right, continuing our work on the t-shirt shop problem. We've identified our variables. We've built a table, identified some points, and of course when x is 0, that's going to be our y-intercept here. And so in our equation, slope-intercept equation, y equals mx plus b, the y portion of the y-intercept, that is our b. So we're going to have y equals whatever our slope is times x plus 15. And then our slope is just our rate of change, or delta y over delta x. And we can see that each time we go up by 1 on x plus 1, we are going up by 8 on our rise, or y. And so slope is the rise over the run, so this is 8 over 1 and 8 over 1. And of course 8 divided by 1 is just 8. So we can write this as 8, or we can write it as 8 over 1. And if we write it as a fraction, this actually helps us when we're graphing. We can know to go up by 8 and over to the right by 1. Of course, you don't have to write it as a fraction. You can write it as just 8x plus 15. Here's our x, our y, and the y is the dollars, and x is shirts. Okay. And so for x, the way we built our table, we're just going up by 1 at a time. So 1, 2, 3, 4, 5. We might have done a different scale. If somebody's setting up an account, they're probably ordering tens or hundreds of short shirts, but you can still build a graph from this. And so our y's are increasing by quite a bit more. Okay, increasing by 8 at a time, that's almost 10. So it might make more sense to go up by tens on our y's. So 10, 20, 30, 40, 50. And they do not have to be the same scale, your y-axis and your x-axis. They can be a different scale. And so our first point, 0, 15, start at the origin. 0x means we do not go right or left. And 15y means we're going to go up by 15. It's halfway between 10 and 20. And 1, 23, so we're going to go 1 to the right, 23 up. It's just a little bit above the 20. And 2, 31, so 2 and just barely a smidge over the 30. And make our line that represents this equation here. Okay. Now in reality, you might actually want to make this more of a discrete graph with just dots, because you're not going to order half of a shirt. And so if we did that, it would actually look something more like just a series of dots. Kind of like that, without this tail down here at the end. Okay, moving on. All right, we're going to do one more of these in the video. I encourage you to try the rest on your own. And so this last one we're going to do in the video, plumber. When a plumber is called, the cost of the service call is $50 for him to show up. So just for him showing up is $50. Okay, and then plus $25 per hour. So if he shows up and nothing's wrong, you know you were able to fix it while he was on his way, you still have to pay the $50. Okay, and so our price for dollars is going to be dependent, and hours is going to be independent. And if you have trouble figuring these out, a good rule of thumb, not always, but usually, your time is going to be independent X, and money will be dependent Y, usually, but not always. So do be careful about it. Don't just automatically put those. Okay, so 0 hours, he shows up and it's already fixed. Okay, just for calling him out, or her, is $50. And then if they work 25 for 1 hour, so let's say that it's 2 hours. So 2 hours times 25, that's going to be another $50 plus the 50 for the service call. So that's going to be 100. And another 2 hours, that'll be another $50 on top of the 100, so that's 150. We've got 0, 2, 4, and of course this point right here, where x is 0, that is our y-intercept. Okay. And so for our slope-intercept form equation, the y value of the y-intercept, that's our b. So we're going to have y equals whatever our slope is times x plus 50. And to get our m, our rate of change, our slope, we just need to find out how we're changing over time here. And so each time we go up by 2 hours, we're going up by $50. And then to get our slope, we divide our delta y by our delta x. So 50 divided by 2 is 25. 50 divided by 2 is 25. They're the same. So we have a constant rate of change of 25 over 1. And we can build our graph. Got x hours and y dollars. And x is hours. We're not going to be looking at 10s and 20s of hours for some plumbing work. So let's go up by 1s here. But we are going up by quite a bit on our y's. So let's go ahead and make these maybe 25. So 25, 50, 75, 100, 125, 150. And then we just plot our points. Oh, and I didn't label this. So this is going to be 150. So 0, 50, that's going to be 0x and 50y. And 2x, 100y. And 4x, 150y. And he might work, or she might work, a half hour or a quarter hour, so we can connect these points in between. Pretty terrible line. Let me fix that real quick. Alright, that's a better line. Alright. That wraps up this problem here. Again, encourage you to try the rest on your own. Good practice, and it can help your grade even more. Make sure to think carefully about what is the independent variable, what's the dependent variable on each of these. For this one, I'll give you a hint that it's going to be a negative slope, the car value. So be careful of that. See you in class.